In this lesson, we're going to discuss multiples and factors. So first of all, what is a multiple? Well, a multiple of a number n is the product of that number and some other whole number or counting number. All right. So for example, 2, 4, 6, 8, 10, 12. These are all multiples of 2, whereas 3, 6, 9, 12, 15, 18, etc. are all multiples of 3. Okay, because you're multiplying 2 times 1 or 3 times 1. All right. And then if you look at these multiples of 2, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, etc., etc. So these are all multiples of 2. So let's think of maybe some multiples of 5, because that's another one we work with a lot. 5, 10, 15, 20, 25, 30. So whenever you're counting by a number, you're actually finding its multiples. Now, we also can talk about divisibility. A number is a multiple of another number if that number is divisible by the other number. Okay, so let me work that out for you, okay? Because I realized that was kind of complicated. So we use the letter m and n, all right? If m is a multiple of n, then m is divisible by n. Example, 15 is a multiple of 3, so 15 is divisible by 3. That means you can divide 3 evenly into 15. 15 divided by 3 is 5. All right. So how do we know something is divisible by a particular number and therefore is also a multiple of that number? We have some divisibility tests. 2 is the easiest one. If a number ends in 0, 2, 4, 6, or 8, or in other words is an even number, then it is divisible by 2. However, 3 is actually really neat. And I'm going to switch over to my pen so I can give you an example. Because if the sum of the digits is divisible by 3, then the number is divisible by 3. So, for example, 123. Is that a multiple of 3? Well, what I'm going to do is I'm going to do 1 plus 2 plus 3, which is 1 plus 2 is 3, plus 3 is 6. Well, 6 is a multiple of 3. I could do 6 divided by 3 as 2. So I know 123 is also a multiple of 3, or is divisible by 3. So there you go. All right, next up is a divisibility rule for 5. If the sum of the digits, rereading number 3. If the last digit is 5 or 0, then it's going to be a multiple of 5. Okay, so 25 ends in a 5. It's a multiple of 5. 1040 ends in a 0. So it's also a multiple of 5. 6 is going to have a divisibility rule that combines two other divisibility rules. So if it's divisible by 2 and divisible by 3, then the number is divisible by 6, because 2 times 3 equals 6. Well, what would be a good example of that? Well, if I think about the number 96, okay, 96 ends with a 6, so it's even, therefore it's divisible by 2. And 9 plus 6 equals 15, which is a multiple of 3. So I know 96 is also a multiple of 3. So because it's even and a multiple of 3, that means that it is a multiple of 6. And I can divide 6 evenly into it. All right, our last one that we like to use a lot is 10. If a number ends in a 0, then it's divisible by 10. So how do we use that? Where does this go? Well, we are now going to define something called a factor. If you can multiply two numbers to get another number, those two numbers are both factors of the bigger number. So, for example, 72. You can break 72 down into 8 times 9. So, since you have 8 times 9, 8 is a factor of 72, and 9 is a factor of 72. All right? So, we can label the product that each independent piece of the product is a factor of our number over here. Now, you can also factor 72 in a lot of different ways. So you can do 1 times 72, 2 times 36, 3 times 24, 4 times 18, and 6 times 12. That means that we have every single one of these numbers in one of these products as a factor. So 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Just as a method that I like to use to organize my information, when I am trying to find all the factors of a number, a lot of times what I'll do is I'll make a little table. I'll start with 1 and say 1 times what gives me 72? All right, 72. 2 goes in as well, 36 times. 3 works, and that's times 24. 4 works, and that's going to be 18. 5 does not work because it doesn't end in a 0 or a 5. 6 works because 2 and 3 both worked, okay? And when I divide by 6, I'm going to get 12. And 7 doesn't work because when I try that, I can see that 7 would go into 70 evenly, but 72 is only 2 away, so it doesn't work. All right, but 8 goes in 9 times, just like we talked about right over here. And so then my next number would be 9, but I've already written that down. So this organization method kind of makes sure that I get everything without missing something. So I recommend doing that if you're stuck on factoring a number. All right, what is a prime number now? Well, okay, a prime number is a number whose factors are only going to be 1 in itself, okay? So, for example, 2 is a prime number because the only way to write it as two numbers multiplied by each other are 1 and 2. So, 1 and itself. Fun fact, 1 is not a prime number because 1 and itself would be 1 and 1, which is repetitious, therefore, or repetitive? Math teacher, not English teacher. Not sure which one of those is right. So 1 is not a prime number. The smallest prime number is 2. All right, so the other type of number we have is a composite number. Composite numbers are numbers that you can multiply two numbers that aren't 1 in itself together. So for example, 4, you could write as 1 times 4, but you could also write it as 2 times 2. Because there is some other option other than just 1 in itself, that makes it a composite number. 7, there's no way to break it down other than 1 and 7, so that makes it prime. 12, you could do 1 and 12, 2 and 6, 3 and 4. So because there's, again, more than one way to factor, that makes it a composite number. So if we want to do something called prime factorization, which is break something down into only prime factors, we are going to generally do what's called a tree. Now, we call it a tree because we have one part and then it branches out into more. So to do that, you're going to take the number you're trying to factor and you're going to break it up into any two things you can think of. It is best if you can start with something that is a prime number just because it's tidier in the tree, but you don't have to. If you can't come up with a prime number that works, just pick anything you can find. So first of all, 80 is an even number. So I know that I can pull out a 2. 80 can be written as 2 times 40. So I branch down into those two things. 2 is a prime number, so I'm going to go ahead and circle it because that's the end of a branch. Now 40, I think to myself, okay, how can I break up 40? Well, it ends in a 0, so that means that I can divide it into 10. Okay, great. I can pull a 10 out. So 40 is 4 times 10. Okay, neither of those are prime, so I'm going to have to keep going. 4, I can break down into 2 times 2, and both 2 and 2 are prime. And 10 I can break down into 2 and 5. That should totally say 5 there. All right, so because we can then say 5 is also prime though, we're going to be able to stop there. And then we write down all of the numbers we just did. So 2, 2, 2, 2, and 5. So that's 4 2s and a 5. You can also write this as 2 to the 4th times 5 if you want to use exponent notation. So one thing I do want to point out to you here is that it is a good idea to be able to identify the first few prime numbers. So I'm going to list them out for you just so that you have them on hand. 2 is prime, 3 is prime, 5, 7, 11, 13, 17, and 19. So these are the first few prime numbers. You'll notice 2 is the only even prime number because every number that's larger than 2 that is even is divisible by 2. So that means it's not prime. All right, so again, here are the steps for finding prime factorization of a composite number. You want to find two factors whose product is the given number and use them to create the two branches. If a factor is prime, that branch is complete. We're going to circle the prime number. There you go. If it's not prime, you're going to repeat the process by writing it into a product of two more factors, and you're going to continue that process, okay? Then when you're all done, you're going to write the composite number as the product of all the circled primes. Now, the other thing that we want to talk about is the least common multiple, because a least common multiple is a multiple that is shared by two numbers. So it's a multiple of, in this case, our example would be of 6 and 14. And there's actually an infinite number of shared multiples because you can go up to really huge numbers. All right. But we want to often find the smallest shared multiple, which is why we call it the least common multiple, LCM. So one way we can do that is by listing out all the multiples, well, maybe not all, but many of the multiples of each number and look for the smallest number that appears on both lists. So for example, if I count by sixes, I get 6, 12, 18, 24, 30, 36, 42, etc. All right. If I count out by 14s, I have 14. 14 times 2 is 28. 14 times 3 is 42. And I actually can stop there because I see right away 42 matches on both. Okay. You'll notice 14 doesn't match on both and 28 doesn't match on both. 42 is the first one. So because that's the smallest number that appears in both lists, it's the LCM of 6 and 14. Now, what about 48? Let's go ahead and factor out 48. So we think to ourselves, okay, how can I break down 48? Well, 2 works because it's even. So I'm going to go ahead and do that breakdown. I'm going to pull out a 2, and that's going to leave me with 24. I circle the 2 because that's prime. Now, how do I break down 24? I need to think of two numbers that multiply to give me 24. So I'm going to do 4 and 6. But neither of those prime, so I'm going to have to continue further. 4, I can break down to 2 times 2. Both of those are prime, so I circle them. And 6 I can break down into 2 times 3. Both of those are prime, so I can circle them. So here I can say 48 is 2 times 2 times 2 times 2 times 3. 4 twos. All right. Now let's try and use that strategy of breaking things down, okay, in order to find the least common multiple. Because I know you're like, okay, we did multiples and we did prime factorization. Why did we do that? Okay, so multiples, we need to use that prime factorization method to simplify things because sometimes it's going to be hard to list out those multiples in a big list. All right, so what's another way we can go about finding that least common multiple that doesn't require us to write out big giant numbers? So we're going to break down the two numbers we're given. So in this case, 12 and 18. So starting with 18, I can think of it's 3 times 6. 3 is prime, I circle it. 6 I break down to 2 and 3. 2 and 3 are both prime, so I've circled them. All right, so 18 is already simplified into my prime factors. Easy peasy, right? Ta-da! 12, I can think, okay, 12 is 3 times 4. I circle my 3. And then 4 breaks down into 2 and 2, so I circle my 2's. So how does that help me with my least common multiple? Well, we're going to list out the primes. I usually do it smallest number to largest number, okay? So 12, you'll see we have 2 and 2, and then a 3. 18, we have 2, and we have 3 and 3. And I do line them up, okay? So 2's, they share, and then 12 has an extra 2, and I leave it blank in the 18 column. Then I have 3's in both, and then I have an extra 3 in the 18 column. So you leave a blank anywhere that it doesn't repeat for a number, okay? And you always create a new column. Again, in increasing order will be the easiest way to do that. Now, for each column, you're going to carry down a number. So these 2's get shared, so we're going to carry down a 2. But there's an extra 2 as well, even though it doesn't match, you're going to carry down another one. So basically, you carry down whatever number is in each column once. When you multiply out that value, it's going to give you the least common multiple of your two numbers. So in this case, the least common multiple of 12 and 18 is 2 times 2 times 3 times 3, which is going to be 36. All right, I hope that kind of gave you a good idea of what a multiple is, what a factor is, how prime factorization works, how that can also help us find the least common multiple. And go ahead and get some practice done.